Back to math. Today, Module 3, Lesson 2. Make equivalent fractions with sums of fractions with like denominators. We try to make these as long a titles as we possibly can. We love it. All right, I put a number line here, so I'm just going to put a 0. Now I'm going to make this one. This is 4/9 plus 1/9. So I'm going to put down just a bunch of lines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what is this one right here? This is one whole, right?
Right.
Why? Because this, our one whole, is cut up into what unit? 9. So we're going to put 9 down below. And this is how you do it when you don't know what you're doing. What is our fraction for one whole? If the bottom number is 9, what's the top number? 9. You guys are right. Good job. And on the 0, what goes over the 9? A 0. Correct. 9 9s. I'm going to put what I like to call the red rubber ball. Now our red rubber ball is going to be what we're going to use to put on the 4/9. Remember? 4/9 plus 1/9, right? So I'm going to put my red rubber ball on my, where is it right now?
4/9.
It's on 4/9. And I'm going to move it up how many times? Once. So my answer is going to be 5/9. And that's how you do addition of fractions with the same unit number on the bottom. Now what I'll do is I'm going to take this off. You don't need to erase yours. You can make a new line. Okay, what's our next one? We have fourths, right? So how many units am I going to count up from 0 to get one whole?
4.
I'm going to count up 4, right?
Right.
Okay. 1, 2, 3, 4 fourths. What's this?
One whole.
One whole. And this would be 5 fourths if we were going to count up, right? This becomes a what? What does this become? It becomes a improper fraction, does it not? Is that correct? Why are these improper fractions?
Because they're bigger than the
If you notice, they're bigger than the 1. So anytime we have something with the top numbers bigger than the bottom number, we have at least one whole in there, don't we? All right, so we're going to do 1/4 plus 1/4 plus 1/4 plus 1/4. What am I going to do? I'm going to use my red rubber ball again. And let's put it on 1/4. You see it on 1/4?
Yes.
What are we going to add to it?
4.
1/4. Right? That's that one.
Yes.
Now let's add this next one. There we go. And then we're going to add our last one. Is that correct? So 1, 2, 3, 4 fourths, right? I'm going to move my red rubber ball just in case I want to use it again, okay?
Yeah. Okay.
So what's our answer? Our answer to our problem is 4 fourths. And what does that mean?
One whole.
That means one whole. Anytime you have the same number on the top as on the bottom, it's one whole. Even if I had 1,500 on the bottom and 1,500 on the top, what would this equal?
One whole.
You are correct. This would equal one whole. So it doesn't matter how big the numbers are. It's still one whole if it's the same number on the bottom as it is on the top. Does everybody understand?
Yes.
Okay. I want to make up a problem for you. Let's say that I'm going to add those fourths, and guess what? I'm going to add 2/4 to it. Are you guys ready?
Yes.
Well, let's get our red rubber ball. We won't sing the song. We're starting with this one, right?
Yes.
So where do we start? We start on the 1/4, right?
Yes.
And then we're going to add this one.
Yes.
That we just added that. Let's add our next fourth. Our next fourth after that, that would be 4/4, right? Like we ended up last time. Now what are we going to do? Add 2 more, right?
Yes.
So 1, 2. And that makes it what?
6/4.
6/4 is correct. Question. 6/4, how would we write that? How would we write this 6/4 into a mixed number? This is a improper fraction. What's the mixed number? The mixed number is a 1. You see it right there. And how many fourths are we over?
2.
1 2/4. So we could put 1 and 2/4. That doesn't look much like a fourth, but it's supposed to be. I know. Okay, so it's 1 and 2/4. Get it? 1 is right here, and 1, 2, 2/4. Okay? Is everybody good with that?
Yes.
All right. If you notice, down here is kind of a tricky, looks like a tricky problem, doesn't it?
Yes.
What does it actually say? It says 2 times 3/5, right? So I'm going to get rid of this. All right. First off, I'm going to draw my 2 boxes. Because when I say 2 times 3/5, can everybody see that okay?
Yes.
That means, remember in the past, that's 2 copies of 3/5. So it's like we have papers, we have 2 papers, and we put 3/5 here and a 3/5 here, right? Does that make sense?
Yes.
Okay. And multiplying them just means we have 2 copies of them. Okay? So can we do this problem?
Yes.
Well, multiplying is multiplied adding, isn't it? So I can just add these 2 together, right?
Right.
So 3 plus 3 is
6.
6. And what's our unit number?
5.
Good job. And then what do I have left to add to it?
1/5.
1/5. So it's going to end up being
7/5.
7/5. Okay, what if we use this as our 5th, as our number line for fifths? Would that be okay?
Yes. Yeah, sure.
All right, so it's 1 over, what's our unit number? 5. 1/5. Come on. 2/5. 3/5. 4/5. Tell me when I get to a hole. 5/5.
1 whole.
There's 1 hole. Yep. 6/5. Improper fraction. Good job. 7/5. 8/5. And 9/5. Okay. Now let's get our red rubber ball. Okay, let's try to get our red rubber ball. Our red rubber ball doesn't want to help us today. So we'll make a new red rubber ball and get rid of this one. I know, sad, isn't it? I liked our rubber ball too. All right. There it is. Okay, so we had 3/5, right? There it is. And then we counted over how many 3/5?
3.
1, 2, 3. It gave us 6/5, right?
Yes.
Is that what we have there?
Yes.
And then we added how many more?
1.
One more, and that came here, right? So what was our answer? 7/5. 7/5. Now, what is that in a mixed number? We have our 1 whole right here, right?
Yes.
So we put a 1,
Yep.
and then how many fifths? Beyond a 1. 1, 2. So we put 2/5. Does that make sense?
Yes.
Everybody understand?
Yes.
Good?
Yes.
Excellent. All right, let's go to one of our last problems. We have 6/11ths. So I'm going to put a 0. 6/11ths. Okay, if you notice, I put down 11/11ths, which would be 1 whole. But we're only talking about how much? We're only talking about 6 of them, right? 1, 2, 3, 4, 5, 6. Now it says you need to break them up into what? Equal fractional parts, right? And we can either use 2 fractions or 3 fractions, right?
Yes.
To make up 6/11ths. So, which way could we do it? Well, 6 can be broken up into, I'm going to use a red for this. I bet you if we break it up 1, 2, right? Is that correct?
Yes.
3, 4, 5, 6. Okay, so each one of these boxes would be how much? 2 11ths, right?
Yes.
And this would be 2 11ths, right?
Right.
And this last one would be 2 11ths. So this would equal 6 11ths. That's what we started with, and they wanted us to break it up that way, right?
Right.
Does that make sense?
Yes.
That's fractional parts. Can I make it in any other fractional part way? Can I make 6 11ths into any other fractional way? This time I'll use blue. Okay? I can go like this. 1, 2, 3, right? And 1, 2, 3, right? What do I have? I have 3 11ths plus 3 11ths, and that makes what? 6 11ths. Is this the same as this?
Yes.
Yes. So I made 2 different types of fractional parts that were equal fractional parts, and so both of these answers would be correct. Both of the answers would be correct. Now what if we had 9/4? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I'm calling them fourths. 0, 1/4, and this would be 9/4. Is that correct?
Yes.
Okay, now I could break this up, right? Super easy. How can I do it? There's only one way I can break up 9, isn't there? Into equal parts. I can't break it up into 2s, can I? No, I can only break it up into 3s. So I'm going to go 1, 2, 3, right? And 1, 2, 3, right? And then 1, 2, 3. So I'm going to have 3/4, right? Plus 3/4 plus 3/4, and that equals 9/4. Do you see how that's done? So I broke it up into 3 equal fractional parts. You know me, I love math!